Welcome to this EMMSAD presentation in the track of software-related modeling. In this presentation we will explore different research ideas related to software engineering. But before to start, I will give some contextual information. My name is Marcela Ruiz. I'm a passionate researcher and teacher in software engineering at the Zurich University of Applied Sciences in Switzerland. Our campus is, as is presented in this picture, this is the Technicum building in the School of Engineering, which also has an Institute of Applied Information Technology. Our university is located in the beautiful city of Winterthur, is super colorful, in which in this picture you can easily recognize the building. I just showed you in the previous slide, but I can also show you where my office is. It's in one of these small houses in the middle of the city center. And in this building is where our laboratory about virtual software engineering is taking place. So I'm the leader of the virtual software engineering lab in our institute, and currently we are exploring a very interesting research idea which is related to: can we design software as we talk? Can we achieve such an interesting dream? So let's see what is our main motivation to pursue that research line. Our efforts basically are focused on supporting successful digital transformation. What it means? So, any digital transformation is driven by software technologies that improve manual processes. So, for us, supporting digital transformation means creating software products with high quality and being able to keep a quick delivery pace demanded by the constant introduction of new devices and technologies in the workplace and society. The issue is that while we create software, we face different challenges. So, modern software development teams, they use user stories, as you have heard in your daily life. They use these user stories to specify software requirements. Okay, so these teams are quite happy collaborating, discussing, specifying things, and collaboration between software engineers and domain experts becomes the core of the success of this project. So they face many different challenges, and things can become quite difficult, especially when all these team members, they need to keep engaged, they need to use the same type of documents, they need to specify requirements. During ongoing discussions, they need to keep their stakeholders involved. So these user stories, while they are discussing, they keep evolving in a dynamic way. So we need to introduce constant change during these software elicitation sessions. We need to consider that there are different resources for collecting requirements, like flip charts that are drawn during the discussion. There are different documents, maybe pictures they take from certain models that they have specified in different meetings, pictures, emails from clients, desires from stakeholders, and this comes from different resources. And this makes it super complex because we have a variety of documents that we don't know how complete they are. They all need to be aligned. We need to have repositories to support them, so that becomes quite a burden at the moment to collect all the necessary information for specifying the requirements of a software. When these teams, if we consider that usually these teams are distributed in different geographical locations, this becomes even worse. This is basically they need to try to interact, collect exactly the same type of resources in order to discuss, specify the user stories. On top of that, after this first meeting, there is a set of user stories that they manage to take note of. Then they need to go to a post-processing session in which all these user stories are again reviewed. There are some peer reviewing activities among the different members. Stakeholders have to review them again in order to ensure that indeed all the specifications are clearly stated. So how can we approach this? How can we improve this? Because currently we can observe that all this post-processing information everywhere can lead to software delays because it takes more time in order to organize all this situation, but also the poor collaboration among the members. It's very difficult for them to try to communicate and to have a central place where they can specify their software and have access to it. So what if we think about implementing very nice and interesting technologies in order to develop software. What kind of technologies we need in order to bring software development step forward? So what if we think about involving virtual reality systems for software design? We consider an ideal room, like a special room that helps us to specify requirements engineering by making use of virtual environments. So in our group, in our lab of virtual software development, we are exploring how we can introduce virtual reality systems for software design. So for this we are currently setting up our virtual requirements engineering room that help us to specify requirements as we talk. So now I'm coming back to the main objective of this talk. How can we specify software as we talk? So of course, we need a specific setting, so we need a virtual requirements engineering setting in which we have different collaborative tools which allow all the members to interact easily. On top of that, I would need to have some methods and tools in order to generate user stories as we talk. So all the requirements, they need to be specified when they are discussing them. For this, we are basically now making use of different techniques like deep learning, but we are also in the process of involving different machine learning and deep learning processing techniques. Since collaboration is a very important topic when developing software, especially when specifying requirements, we are also exploring other technologies like double robots, interactive whiteboards, because our main objective is to be able to embody remote participants. So they can all interact, they can all share and being able to participate regardless of the location and also regardless of the type of information or the type of support where the information they have is shared to the rest of the members. So by having such a setting, we can help to fulfill our main goals, which is software quality. So we have more precise requirements because all these requirements are specified directly from the discussion of the participants without taking into account any post-processing, trying to collect information from different resources. So we would have everything completely digitalized, but also that would help us to achieve our goal of rapid delivery because the tools would support me so I can do it faster. How can we make these special virtual reality systems for software design become something real? For our research strategy, we are going to divide this problem in three main parts, okay? One is, let's try to follow similar solutions from some authors in the requirements engineering field who find or who have already classifiers in order to identify functions and rationale. Then we would have two parts that conform a user story. And what about the roles? Okay, so how can we handle it? How can we discover the roles in the discourse? That is a different problem. And at the end, once we have these three parts, then we will need the glue. In this slide, I have a plus symbol in order to identify the glue among all these parts. That would be like the next step. So we decide to, okay, let's take this approach to try to find the different aspects of the user story, function, rationale, role, and then the glue in order to have them all together. Let's see the techniques. Especially in this presentation and in this paper, we report our progress on our deep learning classifier. It's one of the components we already developed. This deep learning classifier contributes to find functions and rationale, which is great. So we have two parts of the user story. And we also report on how we have designed something that we call ontology crawler. This is also a component that helps us to identify roles, functions and rationale from a specific context. Now let's see how this works. Let's start with the deep learning classifier component. What is the objective of this component? Mainly what we want to do is to imitate the classification process that has been already done by using machine learning. Why are we doing this? If I go to see the related work of some colleagues who have done this already in the past, they have used machine learning classifiers. And this is quite interesting because they point out like, okay, you can use some machine learning classifiers over some label data that you can start to train your models and discover functions and rationale, okay? just these two aspects. Basically because they have also recognized that extracting the roles out of this discourse is a very challenging task. So they focus basically on extracting functions and rationales. We decided to explore deep learning as a different technique in order to see if, according to the context, we could have different levels of accuracy. Here in this slide, we also show the output of algorithm that we have built. We have produced an algorithm that you can also download from our GitHub account. It's free and you can download it and play with it, etc. It doesn't have a great level of accuracy, it's still 33%, so this is not great, but at least we have a specific base algorithm that we can keep training. For this, we use a specific technique, and the technique that we use is turns. So we are not basically exploring sentence by sentence, we are exploring turns. Turns is when the different speakers are giving or introducing certain information or discussing something. So we go basically speaker by speaker in order to discover all the functions and rationale in the discourse. So this is a technique that is used in natural language processing, and this is the basic technique that we have basically implemented in this deep learning algorithm. So in action, how it works. So what we do is that we make use of a global vector, basically for word representation, in order to identify the semantical similarity between the words. Now our third challenge is to identify roles. So for this, our main objective is how can we extract the roles from the requirements elicitation sessions. So from here, we have been discussing, okay, what if we make use of ontologies? Because ontologies are source of knowledge, you know, so according to the context, I can clearly identify which are the most important concepts, the relationships among them, but also the main actors that take part of such a setting. What I can possibly do is, let's take the ontology, crawl it, let's explore it, and then specify a set of foundational user stories that would help me later to identify the potential roles that would take place in different contexts. We are exploring these different machine learning classification techniques. We want to improve the level of accuracy. So as I said, we want to have this plug and play setting in which I can put different techniques in order to classify and select the best, okay? So we would like to select the best, the one that gives us a better level of accuracy when classifying. We are currently working on gluing the different parts of identified user stories, and for this we are exploring the use of neural networks as a possible technique. So the idea is to be able to build the trees so that we can have all the different components, the different concepts, so that we can start to glue the user story and have more coherent sets of requirements and specifications. Other idea that we also explore as a future work is to select the ontologies in an automatic way in order to support the contextual identification of roles. So currently it's not very optimal if you need to ask the analyst to choose specific ontology or build one. So it would be much better if we can just directly suggest the most appropriate ontology from a set of ontologies or repository of ontologies in order to provide this foundational set of user stories that help in the automatic identification of roles. And finally, of course, we are working on validating all these ideas. One of the main problems that we see is the lack of data, as I already mentioned. This has been also recognized by different authors. So if you have recorded requirements engineering sessions, I would be extremely happy if you share, so that would be really great, because one of the main issues that we have here is the lack of understanding and also having sets of data, unstructured data, that would help us to see, okay, how can we test if this classifier works in this context. So to conclude, I want to say that thank you very much for your attention. I'm really looking forward to discuss these ideas together with you, to have a virtual coffee or a face-to-face coffee once we can afford to do that. So I would be really happy to discuss all these ideas together with you very soon. So thank you very much for your attention, and we keep in touch in EMMSAD. Bye!